Okay. Thank you very much for joining me today. We have a wonderful program for you today. A number of companies, a number of people have put together a nice initiative. We're going to go over that step by step. You probably have heard by now, we went through this program. We presented OAM specification in March at OCP Summit. Based on that, it was immediately clear that we needed to build a system. And the system that we thought that we would build would be better if it were in a modular way so that it could be interoperable in multiple chassis, multiple systems. So we formed a group, we called it OAI, Open Accelerator Initiative. We started working on multiple chapters. Today is basically a progress report on mainly the first two chapters, OAM and UBB. However, to make the UBB, the Universal Baseboard, work well, we also had to address some of the issues in other chapters as well. So, in general, you know that the world of artificial intelligence is growing fast. Machine learning, deep learning, HPC are driving a lot of innovations in accelerators. And based on each accelerators in the past, you've seen a number of platforms built. We've done all of those things, and we know how to do them again. But we learned that doing things together, we can go farther. So the team got assembled. We are tackling all of these different solutions, are looking for solving similar problems. We thought that we definitely need an open source solution for all of these very complex problems, and expensive solutions perhaps could be shared by multiple companies, either in the form of supplying or in the form of using them. So we thought that if we had an interoperable modular system, then we could accelerate innovation as well. If different companies, as users or suppliers, needed to change a portion of the design, they could do that independently. So we built the whole system around a modular building block architecture. So at the beginning, we started with the definition of the accelerator module itself. The accelerator module itself, as we suggested last March, is in nature, it is similar to a PCIe solution. However, it has a different form factor. It is trying to address more interconnect links at higher speeds, and it wanted to support much bigger power envelope. So that's the size and shape of the module that we have today. A little report on the spec on OAM. It is at 1.0 already. It is defining the mechanical and thermal envelope and the interconnect for peer-to-peer and OAM to host. It is based on a suitable connector to be high speed. It starts with the connector itself is capable of 56 gigabaud or 112 if it is in a PAM4 format. But it will be limited by the environment that it gets plugged into. For example, the UBB that we're designing right now is going to have some insertion loss, so we will have to accommodate for that. Our main target now is 32 gigabits per second, similar to what the PCIe Gen 5 might be doing. So that is our target now. Of course, from the mechanical and thermal aspects, there is already a reference heatsink design. Thank you, Tiffany. But be aware that this solution could be up to 2 kilograms. So it is going to create some challenges from handling and modularity as well. So that's where we are on OAM. We are adding the remaining infrastructure solutions around OAM, just the module. So we need to have a baseboard to do the correct topology appropriate for different accelerators. And we need to interface that universal building block or universal baseboard to a host. Host normally is a collection of CPUs. So we need to have a module for host interface board. These days, it is fashionable, it is normal to use PCIe switches for host interface board. However, in the future, we see that there are different host interfaces might be possible. CXL is a good example. Okay, all of these solutions need to be in a mechanical, feasible, serviceable item. We call that a tray, OAI tray. Within standardization on OAI tray, we can actually move all of these modules from one chassis to another chassis. Then we have to build powering and cooling around that. The system is designed for air-cooled or liquid-cooled solutions. And at the end, we need to manage the system. For the management of that, we have a chapter dedicated to secure control module, specifically done for the OAI chassis. The concept is modular in every way. It is done on the logical and physical boundaries. For the physical boundaries, we have OAM, UBB, host interface board, power distribution board, tray, chassis, system management controller, secured control module, and some sort of expansion solution. On the logical aspects of that, we have power and cooling, electrical, dimensions, mechanical, and security and management. So solutions can be built independently, and they could declare that they are compatible with whichever spec they want to follow. We just don't want to limit innovation. The system specification is going to be hierarchical. We will have a base specification. Based on the base specification, different designs are possible. For example, we might have a host interface board definition, but there might be different variations of that, or different designs. And based on those designs, there might be different products from different companies. That is how OCP Server Project works. We have base specification, design specification, and then products. So as long as we have defined boundaries for these modules, we can expect for them to be interoperable so that we can create an environment for fast innovation. As an example, the security and management aspect of that, yes, normally we need to have a BMC. Nowadays, it is important for us to be careful about security, so root of trust chip, it will be part of this. We need to be careful about updating of firmware without reboot. So a number of these things we will eventually talk. We don't have a chapter specification on this topic yet, but it will come. Just for you to have a visual, the universal baseboard is organized in this shape. The size of OAM from the beginning, it wanted to go from, take advantage of all the horizontal space of a 19-inch rack baseboard or motherboard. So that's one of the reasons that one of the dimensions of the OAM is 102 millimeters. 165 millimeter was really to kind of give it enough space, similar to what a PCIe module had, So put them all together. That is the tiling of the OAMs on a UBB. Then UBB has actually two major sections: the host interface section, and which is on that side, host interface section, and an expansion, the native expansion section. Native, we call it native because we expect OAMs to go directly through these the QSFP DDs out on their own native protocol. So to get organized and approach this problem in a modular way, after submitting the OAM specification, the three companies got together and initiated the OAI. And then we started asking our friends to please join us. And I'm really pleased, happy, and very extremely excited that we have a number of companies showing interest in this open accelerator infrastructure. We formed a group to protect individual IPs. We have a joint development agreement. This group of people are working together to develop this specification, and we will publish this specification in different revisions, 0.3, 0.5, and eventually, hopefully, 1.0 soon, to the OCP community for feedback. Based on the work that's been done so far, good people, good companies come up with 3 different reference designs. You probably have already seen them at the OAI booth. They're targeting different applications. 19-inch, 21-inch rack, stacked, shallow versus coplanar deeper chassis are all covered with different features. So again, the work that we're doing is hierarchical, very similar to what we do at OCP Server Project. We have a base specification, design specification, and products, really to eventually provide good enough incentives for adopters, for people who are going to eventually pay for these solutions. And it's very similar to what I learned from Van Gogh. Last time I was here last year, went to the museum, Van Gogh Museum, and Van Gogh had some of these nice quotes. He was comparing his work to the work of the musicians. It's that a composer comes up with some definition of music, and the conductor sits there and thinks about it and comes up with different interpretations of that. And eventually a musician implements a very good work of the conductor and composer. And of course, the audience has to like it. If we come up with a nice tune, do it right, we will please the audience, and they keep on going and going for years and years to come. Please get involved. We have an organizational structure for OCP Server Project. OAI is an initiative, a subgroup within OCP Server. And you can get involved by sign up for the mailing list. We can move to the UBB. We have a good group of people have already worked with the universal baseboard. There are some presentations on that. Richard, you ready? Whitney and Richard, please.